Okay, session is being recorded and it will be put on our recorded presentations link on my TCC Blackboard pretty soon after this class ends today. So today on the schedule, we're going to cover modules 4 and 5, covering access control lists. And then Thursday, people that want to come for the in-person lab will do the lab 5.2, a lab on access control lists. Before I start on today's stuff, though, I want to show you. Let's see now, I got to click on this. I want to go over to the, let me see, maybe I have to stop sharing this first. Share this, and share this. I think this. Are y'all seeing this okay? All right, good. So the announcements, I posted a couple new announcements. Probably the biggest one here is the Cisco Academy Career Fair, Career Bridge event, which we're doing virtually now. And it's going to be a week from Thursday. And I've put the link in here to click on this. They usually have pretty good information about career opportunities for people in the Cisco networking CCNA type field. I also put a little explanation for your information thing below that on how these modules line up with the 5 chapter exams. So today we're covering access control lists, and when we finish with this modules 4 and 5, you should be prepared to take the second test called network security exam. The IT department was able to put up a Cisco packet tracer application in their VDIs or virtual desktop interfaces. And this is like a VMware type thing where you run a virtual machine. So even if you have a very low capability device, like I tried it on an old low memory Chromebook, it works just fine. So theoretically, you should be able to run the equivalent of a Windows 10 desktop with a high performance machine on any old device as a web screen. So if you want to run packet tracer from pretty much anywhere that you have internet access, you can go to this, click on this link that's on the left-hand portion of your MyTCC Blackboard. Right near the bottom, it says the VDI. You can click on that and pick the student workspace. And once you log into that with your regular MyTCC email account, you will see a Windows 10 desktop. And you'll be able to just click in that search magnifying glass in the bottom, type packet tracer, and you can start and run the packet tracer application. I have put a link in here to the user guide that IT department has published. And if you set that up, you will be able to save files from packet tracer to your Microsoft provided cloud drive type based thing. Because normally there's no way to save it. You just start it over again. Next time you start a new session, you won't have any previously saved stuff. But you can hook it up, in that user's guide. It gives you details on how to hook that up to the cloud-based, not the Google one, but the Microsoft-based equivalent of their cloud drive file storage space where you can save stuff to that. And you students all get that as a free service, because we have a big fat contract with Microsoft and we buy a lot of Microsoft software from them. So they do that for us. Okay, now let me switch back to go back to our PowerPoint presentation. Hang loose, someone just joining. I'll put them in this role here. Okay, so we're going to start on access control lists. We are taping, we're recording. All right, good. We're going to start on access control lists, which are a security method that's present in Cisco routers and even in some stuff in switches that allows you to do a couple things: put a little bit of security on the network, but also trim up your traffic and get rid of unwanted traffic that's crossing maybe an expensive wide area network WAN link that you want to pay for that. So we want to deny unwanted access to things. So we can do some traffic filtering with our access control lists. For example, think of a network administrator might want to allow users to be able to get to the internet, but don't allow external users to telnet into the LAN to do stuff. Or maybe in a public school K-12 environment, you might want to allow the junior high and high school students access to the internet, but not the kindergartners and lower level school stuff, because there's some national regulations. If you're under 13, you're not supposed to see stuff that's on the internet. So you could use it as a tool for doing that. So routers give us some base. It is not a full-featured firewall. You can do some fairly sophisticated stuff with just the standard access control list stuff that's built into Cisco routers and switches. But for really sophisticated stuff, there are separate firewall products that we can really fine-tune that stuff. And the king, probably the big gorilla in the industry here is Palo Alto Networks. But their own companies, even Cisco makes their own firewall products. That's beyond the scope of this course. So what is an access control list in Cisco? It's a sequential list of permit or deny statements that apply to IP addresses, source and destination IP addresses, or upper layer protocols like TCP, UDP, things of that nature. First of all, we're going to look at standard access control lists, which only filter based upon the source address. Kind of clunky. We'll use that to get going, get started. And then we're going to go on to extended access control list, which can filter both on the source and destination IP addresses, as well as filtering on things like, is it port number 20 and 21 for FTP, or is it port 25 for email, things of that nature. On the topic of dropped topics from the new CCNA exam, there is no longer any requirement to know anything about IP version 6 access control lists. So we don't have to cover that. You just have to know the IP version for standard and extended access control lists. Oh, good. Someone else came in here. Let me put him in. And let's just check on attendance. Okay. So we're going to look at access control lists and how we do the configurations for them. I like this particular author's PowerPoint slideshow because he got a good graphics on showing how you can zoom in on a particular workstation and permit or deny, that type of stuff. So access control lists at the CCNA level, we're looking at just protecting the integrity of the router and its networks. And now at the higher level, CCNP, CCIE level, they have traffic filters, dollar lists, route filters. We don't have to worry about that stuff. That's more extended stuff. If you go to CCNP advanced routing, going for your CCNP stuff after you get your CCNA, you can worry about that. So let's not worry about that today, just the basic stuff. So this is kind of like learning Spanish. There's a bunch of stuff that's taking effect all at one time here, so I'll try to make it clear for you. This is like, teaching networking. It's like trying to herd cats. There's no one good place to start. So we're going to look at some concepts first. So access control list is a sequential series of commands which either accept or deny traffic. And this acceptance or denial of traffic is going to be based upon a specified condition, such as, does this packet have this source address? Or does this packet have this destination address? Or this packet has this TCP port number? Once we define a series of access control lists, we can apply them to a router's interface port in one of the inbound or outbound directions. So here are some things. First of all, we're going to look at something called standard access control lists. The only thing they filter on is the IP source address. The source address that's in, when that packet was created by that source host machine, he put his own source address in there. And then he addressed it to some other destination IP address. So in standard access control lists, we can only filter on the source address. Kind of clunky. In extended access control lists, we are allowed to filter on both the source and destination IP addresses, as well as what port numbers are they, like port 80 for web, port 25 for email. And we can look at this upper layer traffic as well and do some more sophisticated stuff. Like, for example, your home router has a function that will not allow traffic back into your home network unless it's a TCP established connection that's something you ask for. So someone can't just come in and poke data in there that you weren't expecting. Now, unfortunately, there's no more IPX Novell, there's no more Macintosh Apple Talk, but there are other protocols out there besides IP version 4 and IP version 6. And in some legacy environments, you may see some of these old things. Like, for example, I always like to joke and use the example of lawyers' offices and doctors' offices because they're too cheap to upgrade. So they might be using that old Novell server, or they might be using the doctor's got Macintosh Apple Talk when he wants to connect to the network. So when you do define an access control list, it's based upon a per protocol basis. We're only going to be using IP version 4. We could do an IP version 6, but that's no longer required for CCNA. That'll just be CCNP. It's going to be defined on a directional in or out of a particular port, and so for one particular port. So a single access control list, you would write it to control traffic in one direction at a time, inbound or outbound, on one interface at a time, a particular interface, let's say the Ethernet interface or a serial interface. So if I had another direction, if I wanted to control traffic in both directions, maybe I wanted to allow only incoming traffic for port 80 so people can come and see our web server and buy our products, but I wanted to prohibit outbound traffic to, say, FTP, I could write 2 separate lists for this. Now you can have as many directions and protocols as you want for each particular interface. There's no limit to that. So access control list, a group of statements whether packets are accepted or rejected, permitted or denied, coming into an interface or leaving an interface. So they're written in a sequential logical order. As a packet comes into a router, and let's say there's an inbound access control list on the interface that the packet is coming into the router. He's going to look at that inbound access control list and look at the first statement and say, does that source address match the address that's in my first statement? If it matches, then he looks at the end of the statement and says, is this a permit or a deny? And if it's permitted, it passes on just like normal. If it's denied, it's dropped. And the rest of the access control lists aren't checked. If the first statement is no match, it will go to the second statement and check it. And it will continue in this fashion for however many statements there are with permits, denies. Now, very important concept here. There's an implicit deny any traffic that's put at the end of the list by default. It's not visible there. So if you have 5 statements and none of them are matched, the traffic is denied. So that means there has to be at least one permit statement somewhere in your access control list. If they're all denies and the implicit deny any at the end denies that no traffic is to be permitted. And there's a cheaper way to do that. It's called shutdown. So sequential logical order from the top down, once a statement is matched, in other words, except, for example, when we first do our standard, it will match or it will not match the source destination IP address. If it matches, then that packet, none of the remaining statements are used. It skips it. Once it hits a match, it then looks at the end of that line and says, I'm to permit or deny this traffic. So there can be only one access list per protocol per interface. You can have an inbound and an outbound. You could have an inbound one for IP version 4 and one inbound for IP version 6. You could have one inbound for Novell NetWare and one for AppleTalk. But there's always an implicit deny any at the end of every access list. Now look at that bold statement at the bottom. This is very important. Access control lists do not block packets that originate from within the router. So if you plug into the console port of the router and you want to go out the Ethernet port or the other Ethernet port, and there's an access control list that says you can't do that, it's not affected. Access control lists only block traffic that comes into the router from one of the ports. And then he looks at it and says, do I go ahead and process it and send it out the other interface port? So if you console into the router and do a ping or telnet, or even if you secure shell or telnet into the router, it will not be affected by access control list from that. Just ordinary user traffic that comes in and goes out of the router, normal traffic. So first of all, we're just going to look at standard access control lists. Only filter on the source IP address. Then we're going to promote ourselves up to experts, and we're going to go to extended IP access control list. They can filter on the source address, like a standard can, but they can also filter on the source and or the destination and or the protocol number and other parameters as well. So let's do little baby steps here, and let's do standard lists first. Here's a syntax. It's a 2-step process. The first process is I'm going to write a list of condition statements. And if it's this IP address is permitted, if that IP address is denied. And then the second step is I'm going to apply it to an interface port by using the access group command. And I can write an access control list all day long, but they will take no effect until I do step 2 and say, take this access control list that I wrote and apply it to the G00 port in an inbound direction, for example. So it can be applied. So we have to do those 2 steps for this to take place. So there are a range of access control lists that are available for standard IP. We're going to do standard IP first. The range is 1 to 99. So I could have 99 separate access control lists. There is an extended range of these. If you run out of these and you need more than 99, they have given another bank of numbers that are available for that. The range of numbers for extended IP is 100 to 199. And all this Apple Talk and IPX stuff, we don't have to worry about that. That's not in the curriculum anymore. We used to teach IPX. We used to teach Apple Talk, but that was taken out a number of years ago. So here we go. This is what I really like about this guy's graphics. This is a good explanation. So let's see. We have this host machine, and this wording here is this standard English. It says permit. I think it should say permit only the host 172.16.32 to exit the sales network. Let's say that's one that's circled with the red rectangle in the middle of the graphic. That's the manager of the sales department, and he's the only one who's allowed to send traffic to the servers in the engineering department and to the servers in the administration department. All the other plain salespeople that are not managers are not allowed to send any traffic outside of the network. So we want to write an access control list that'll do that. So right now he's the manager. Later on I'm going to use the example of when the boss hires his useless cousin, his useless nephew, and brings him into the company, and won't block him from getting out to Facebook and stuff. But this is the authorized guy. Okay, so here's our task. How are we going to do this? Okay, so on router B, which is this one right here in the center, this is the default gateway for the sales department. And we're going to write a statement that says access list 10, and because it's from 1 to 99, it's a standard access control list. We're going to write an access list 10 and say permit 172.16.30.2. That's the IP address of the sales manager, the head of the department. He gets to have his traffic go to the rest of the company. No one else gets to have their traffic leave. So we're going to permit him to do that. Now, there's an implicit deny any. It's there by default. But we're going to write it out anyway. Here it is. Access list 10, deny, and we'll talk about why these numbers are like this in just a second. This means deny everybody else. Remember our IP route statement, IP route 0.0.0.0.0? And that was a wildcard that means any other possible IP address. So if this sales manager sends out a packet, his source address will match this. His address will match the first statement. It'll be permitted. If it's anybody else in the department, it will not have this IP address. This statement will not match. It will drop down to the second statement, and all of the traffic will be denied. So you can define access control lists without applying them. They won't do anything until you apply them. They won't have any effect. Without apply them to the router's interface. So the question here is, to which port on the router should I apply this access control list we just wrote, and in which direction should it be done? So placement of access control lists is if you apply it in the wrong place, it could deny or permit the traffic you intended, but it could have an unintended effect of messing up other traffic. So you have to be careful about applying them. Now, this is a standard access control list. It should be applied to the interface closest to the destination of traffic. An extended access control list on the interface closest to the source. We'll see why later. Okay, so outbound traffic is traffic that has already been routed by the router and is leaving the interface. Let's remind ourselves of what happens when a router receives a packet. A packet comes into the router through some inbound port. It goes through the routing table lookup process. And then the routing table lookup process assigns it to an outbound port to be sent out one step closer to its destination. So outbound traffic is traffic that has already gone through the routing table lookup process and is leaving the router on another interface. Inbound traffic is traffic that's arriving on the interface and which will be then go to the routing table lookup process. Generally speaking, it's better if we can do inbound, because if we're going to drop traffic, we want to drop it before it goes through the expensive, time-consuming routing table lookup process, instead of letting it go through the routing table lookup process and then be chopped out because we wasted a bunch of processing time on the router. Anything we can do on the router to reduce the size of the routing table and reduce the number of packets that have to be looked up is going to be better. So let's do it on an inbound on this one. So here's our code that we wrote earlier. Here's our two statements we already wrote earlier. We applied an access list 10 to, we wrote an access list 10 that says permit the guy in red from leaving the network, let him do it. Everybody else is supposed to be denied. So the second line denies everybody else. And then we applied it to the interface port E0, the one with the red arrow here. Applied it in an inbound direction. Interface E0. Or we could do it this way. Instead of applying it to an inbound direction to the Ethernet port, let's apply it in an outbound direction to the serial ports that connect the sales department to the administration and engineering buildings, or they're on different floors maybe of an office building. So I could apply it to this serial port. Oh, I'm still writing good. I could apply it to the serial ports in an outbound direction. However, that's not preferable because of the implicit deny any. Legitimate traffic between the administrators and the engineers and vice versa would be blocked because we're only permitting the one sales manager traffic to pass. This would have the effect of totally crippling all network traffic, legitimate traffic between the administration and engineering department. So that second option is bad. We're not going to do this. We're going to do this one. We're going to apply to an inbound direction to the default gateway, 100B's default gateway to the sales department. And we're going to apply it in an inbound direction to that Ethernet port. You can tell this is a really old slide because the Ethernet port is E0 instead of F00 or G0/0/0. Okay, now let's have a second scenario. We're going to allow, in this case, we're going to allow several host machines. We're going to permit them to exit the sales network. The manager and his three top trusted guys. Now, there is another host machine, other host machines that have junior people or the boss's nephew. We're not going to allow their traffic to exit. We're not going to allow them to waste time on Facebook while they're supposed to be doing their sales work. Okay, so before it was just one host, now we're going to do several hosts. So we're going to modify our list and make it do 4 hosts instead of 1 host. Let's see how we do this. Okay, are we still writing? Oh, good, we're still writing. So now I have the original manager and his 3 top lieutenants. All of their traffic is going to be permitted. So if you have the address 30.2, 30.3, 30.4, 30.5, your traffic is permitted to leave the network and go to the rest of the company. What if you have 30.6 or 30.7? Well, it doesn't match. The implicit deny is going to get it. The implicit deny is here in the italics. It's there by default. It says if statement number 1, if you're not .2 or .3 or .4 or .5, there was no match on the first 4 bold lines, it drops to the last line, the implicit deny any, and traffic is denied. If I want to get rid of an access control list, generally speaking in the Cisco iOS, if I want to reverse and negate the effect of any command, I simply repeat the entire command and put the word no in front of it. So if I want to get rid of the entire access list, I say no access list 10, unless I'm on the global configuration mode. Now I should also remove it from the interface. Before I went to the interface Ethernet 0 and I applied the access group 10 in, I should reverse that by putting repeat the entire command and put the word no in front of it. And that'll completely remove every aspect of this access control list from this device. Okay, now let's reverse our scenario. And here we have, this is not the sales manager anymore. This is the boss's worthless nephew who was given a summer job. And he's not going to be able to do any work, so we're going to have to take some steps to protect him against destroying our computers or messing around on the internet. So this is a reverse case. The 172.16.30.2 guy I've outlined in blue, he is not allowed to create any traffic to leave the network. He's going to, everybody else is permitted. And we're going to look at the keyword any here, which is part of the syntax for access control list. Okay, so let's look at here. Our first statement is deny the boss's worthless nephew traffic. If he creates any traffic and he's 30.2, it will not be permitted to leave the network. Now let's look at the second statement. Access lit 10. If you're not the boss's nephew and you have any other IP address, 30.3 maybe, it won't match the first statement. Nothing happens. It'll drop to the second statement and it says permit all traffic. Permit any is a shorthand that says permit all other traffic. So that means that if you're the boss's nephew, your traffic is not allowed. If you're any other, it's going to be permitted. And the implicit deny any will never be executed because the second statement, permit, matches everybody else. This is what I mentioned earlier, is that all access control lists have to have at least one permit in them of some sort. If it's not present, no traffic will leave. And then it's applied in the same fashion that we did before. What if I had put it in the wrong order? Well, let's see now. Now the number one statement is the permit anything, including the boss's nephew. He's 30.2. Well, the permit any matches him. Everybody gets to leave the network. The second statement is never checked because everybody matches the first statement. That's not what we wanted to do. So the order of the statements, the condition statements that you put in an access control list is kind of important. You can either make it work or you can make it not work at all. Now, when an access list is checked on an inbound interface, the packet comes into that interface, and if it's a permitted, it goes to the routing table lookup process. If it's permitted, if it's denied, in this case, the boss's nephew denied, the packet is dropped immediately. It never goes to the routing table lookup process. This is the opposite if you put it on an outbound access control list. If the router has to deny a packet because of an ACL command, he will, as a courtesy, send back an internet control message protocol destination unreachable because it was administratively prohibited to the source machine that created the packet. Okay, traffic coming into the router is compared to access control list entries based upon the order. If I add new statements, they're going to be added at the end. This means if we need to modify an access control list, we generally need to copy it in the notepad and create a new list that's better, and then paste it back in, destroy the access control list, and recreate it. The router will keep looking through the statements in order and as they go through sequential order until it finds a match. If no matches are found, it's the implicit deny any. If there's no matches, no traffic. So frequently hit entries are better at the top of the list. Implicit deny for traffic that's not permitted. So if I have an access control list that only has denies, and there's not one permit, all traffic is denied. That doesn't make sense. There should be some permit statements in there to allow the traffic that you want to be able to leave the network go in there. Now, wildcard masks. Do you remember when we had wildcard masks with OSPF? The wildcard mask is kind of the mirror image or the inverse of a subnet mask. So the wildcard mask tells us how much of this source address we need to check, how much of it needs to match. The zeros mean must match exactly, and the ones mean I don't care. So a wildcard mask is a 32-bit quantity divided into 4 octets, just like an IP address or subnet mask. It's paired with an IP address, like a subnet mask would be. The numbers 1 and 0 are used how to identify the bits, how to treat the bits. So they're sort of related to subnet mask in that they're normally mirror images, or where there were 1s in the subnet mask, there are 0s in the wildcard mask, and vice versa. So normally a subnet mask tells the router, what part of this network is the network address, what part is the host address. Wildcard masks are used to tell in an access control list which bits to check and which bits should we safely ignore. So let's look at this example of this statement here. We're still writing. Okay, good. Access list 1 permit 172.16.0.0. So the 170, this is going to permit all traffic that has a network prefix of 172.16, and their third and fourth octets can be any value. The zeros mean must match exactly. Must be 172.16 exactly. The ones, 255 is 8 ones. 16 ones mean I don't care what your last two octets are. It can be any value and I won't check it. So this access list 1 permit 172.16.00 00255.255 means I'm going to permit you just so long as your first half of your IP address is 172.16. You can have anything for the last half of it. Nothing confusing about that, right? So if we write out in binary, if we write out the 172.16, we get this in binary. We write out the 00, we get this in binary. So the zeros means these binary numbers must match exactly. This is going to match the 172.16. The ones mean I don't care. I'm not testing that. This means that the last half of the IP address can be any value. Any number from 172.16.0.1 all the way to 172.16.255.255 will be permitted. It'll match the statement. So this is a match for us. So matching packets are going to look at 172.16. Anything, any value. So 0 means check the value. 1 means I don't care, don't check it. So matching packets will always be 172. This is the binary pattern for 172.16. Must match exactly. Last 16 bits, the last 2 octets can be any value whatsoever. Doesn't matter, it will match. It won't check it. Okay, now let's use this in our previous example. We want router A to permit the entire sales network, all of these guys, and just the engineering manager, just this workstation, to be able to go into the servers that are on the administrative network. Now, it would be cumbersome if we had to write down all these single individual addresses over and over again. Now, they only showed 2 host machines here in the sales department, but what if there were like 25 of them? So we're going to use wildcard masks to sort of use one line and match an entire network that could be dozens and dozens of machines. And we want to enter so much data in there. Okay, so access list statement 11. Permit everybody that's on the 172.16.30 network, all of these guys, permit them to get to the administration network. So let's look at our wildcard statement here. It's 0.0.0.255. So this means if you have the IP address of 172.16.30, that matches the first 3 zeros, the first 3 octets must match, you're permitted. I don't care what your last digit of your IP address is. So if it's .2, .3, .4, .5, any possible address is permitted. The second statement says, for that engineering boss, 172.16.50.2. And let's look at our wildcard statement. It's all zeros. It means must match exactly. The entire 32 bits must match exactly. That individual workstation only. Right next to them, the 50.3 workstation, it won't match. 2 is not 3. It won't match. It'll be a different binary value. It won't be permitted. Only the engineering boss's workstation will be allowed to leave the network. So in this case, the sales department, everybody is allowed. So we just check their network prefix. Everybody in the sales department is 172.16.30. something. So all we check for is the 172.16.30. We don't check the last octet. You can be any value in that sales department network, and you will be allowed to get out. On the engineering boss guy, we wanted just his host address only, exactly his address only, not anybody else, not even .1 or .3. It has to be exactly that value. So his value was 172.16.50.2, and the 4 zeros mean match exactly. There's no ones in there. There's no don't cares. 0 means all 32 bits must match exactly for this particular individual single unique IP host workstation. And that takes care of just him, and everybody else is not allowed. Oh, forgot to apply it to an interface port. Where should we apply it? Well, in this case, we're going to follow the best practice for standard access control list and apply it as close as possible to the administration servers that are being protected. We're going to apply it to that router port, and we could apply it to the Ethernet port in an outbound direction, or we could apply it to the serial port in an inbound direction. Either way will work just fine. So he's applied it to the Ethernet port in an outbound direction. The implicit deny any, he's written it out here, outlined in red in the third line. Access list 11, right here. Deny everybody else. So only everybody in the sales department and the one engineering supervisor gets to go to the administration server. Everybody else is denied. So this takes care of that security environment for us. So in this case, the test condition was deny everybody. 0.0.0.0 is our wildcard for any possible IP address. And the 255.255.255 says, I don't care, don't check. If you're any address, you're denied. So that takes care of the other people who were previously approved because they were higher up in the list. Okay, instead of writing out all these zeros and these 255s and all those periods, and we're going to fat finger it, and you're going to get an error, and you have to type it in today. Type it in again. As a shortcut syntax, you're allowed to say any. So instead of typing out all this stuff in green, I'll just type the word any. Deny any. Deny means any address. So any is equivalent to 0.0.0.0 space 255.255.255.255. Easier to type. So let's use it in this case. From that example before where we want to deny the 30.2, the boss's worthless cousin, is the boss's worthless nephew is working, and we want to deny his address. And we want to permit everybody else. It's easier to type any than typing all this out. Okay, let's talk about outbound access control lists. The traffic from that's going to be denied is going to reach router A, and it's going to go through the routing table lookup process, and then it's going to be denied. So it's going to be applied to router A. It could be applied to router A's serial port for it to be denied. We're going to use a better process coming up a little bit. We're going to use extended access control lists, so we don't have to put the standard list can only filter on source addresses. So we have to put it really far away from the devices that are giving us problems so that they can protect the server being protected. And all the traffic crosses the company WAN network at great expense and then gets dropped. So extended access control lists are a better solution. Okay, I'm not going to do this. Let's let this exercise for you guys. There is a way of calculating. Here it is. You can take 255.255.255.255 and subtract any subnet mask, and that will give you your wildcard mask. That's their Gonzo secret insider tip of the day. You can also do it works the other way. You can take 255, subtract the wildcard mask from it, and you'll get the subnet mask. Another shortcut method is the host option. Now, I could have typed access list 10, permit this particular address, 192.168.1.100, and the all zeros means must match that at one single host address exactly. As an alternative, I'm allowed to say host 192.168.1.100. It'll take that. So the host option substitutes for having to type out the 0.0.0.0. If you want to match just one exact address. So here we have our two examples down here. We could replace all those zeros, not have to type them, and just type host instead. A little easier to type. Less chance of making an error. Once we've created an access control list and applied it to an interface port, we can type show IP interface, and we can see, in this case, the stuff outlined in red. He has a inbound access control list and it's number 2, so it's a standard. And he has an outbound access control list, and it's 101, so we know it's an extended access control list. Because 1 through 99 is the range for standard, and 100 to 199 is the range for extended. You can also type show access lists and see from the full show run, you can see your particular access list that you've done. Or you could just type show run, you could see them all, along with all the other stuff you get. So here's type show running configuration, and we can see all of this. We can see the IP access groups that have been defined in inbound and outbound directions, and we can see the access list condition statements themselves. So more than one interface is allowed to use the same access list. You can do that. This can apply to inbound lists for IP version 4 to one interface. Okay, access control list operations. Let's look about inbound. So here comes a packet into the router. The iOS, if it's an inbound access control list, in this case, we've applied an inbound access control list to the port Ethernet 0. And so the router says, first of all, is this an IP packet? If it is, he'll say, well, is there a standard access control list on their interface? And there is one. There's one that's been defined. Does the source address match the access control list entry? If not, go to the next statement. Move to the next statement. Continue in a loop until you run out of entries. If you hit a condition statement in the list that matches, permit it or deny it. If it's permitted, it goes on and gets, goes to the routing table, look at process, and gets processed. If it's denied, it goes into this thing here, that's the bit bucket, and we'll send that destination not found ICMP message. So that's how the process goes when it's an inbound list. If it's an outbound access control list, the iOS has to wait for the routing table lookup process to assign this outbound packet to a specific outbound interface. Now, once that is known, he'll check to see, is there an outbound access control list on that outbound interface? If so, apply that. Because the outbound interface is not going to be known until the routing table lookup process, the forwarding decision is made. So that wastes a lot of processing power. If it's possible to architect your solution to go inbound, that's going to save processing time and make the router a little bit more efficient. So standard access control lists. We permit or deny a single IP address or a range of addresses. Only on the source IP address. The default list is 1 through 99. There's an extra set of 700 more if you run out of those. We want to apply them to the port closest to the destination. I'll explain that in a minute. So the full syntax is to create the access list, and we can put a log statement at the end if we want this to appear in a log file for troubleshooting purposes. If I say no access list, that's going to get rid of all my condition statements, no matter how many there are. So if I say access list 10 and create 10 statements, and I decide that I want to delete it because I need to reorder them or something, if I say no access list 10, they're all taken out, and I can use Notepad or something to reorder the statements and copy and paste them back into the router console. Now, extended access control list. This is the one where you are allowed to filter on both the source and destination IP address and things like port numbers. So this uses the range of 100 to 199, and there's another bank of 700 addresses if you run out of those. We have our same permitted deny statements that we would use as before. And now we're going to say, what is the protocol in use? IP, TCP, UDP, Internet Control Message Protocol, generic routing encapsulation, all these other ones that are possible. And now, since we are able to both check the condition of both source and destination addresses, we can type those in. And we'll use our wildcard mask like we did before. And we're also allowed to specify a port number. And we can also say, for example, something wild like all port numbers that are greater than 79 permit. All port numbers that are less than 79 deny. We can do wild stuff like this. TCP established. This means that, the TCP sync act, three-way handshake that takes place, and you establish a TCP connection. This can make your $1,000 branch office Cisco router do everything that a $20 Linksys router would do, which is when traffic comes back into the network, check see if it matches the TCP connection that was already set up. So with extended access control lists, we have this range of 100 to 199. And they're more flexible. They have a greater range of control, but it's kind of like a sword. It's two-edged. It has more versatility, but it's more dangerous to handle. So extended access control lists can check the source and destination packet addresses, as well as checking for not just layer 3 IP addresses, but layer 4 protocols like port 80 for web or port 25 for email. Greater flexibility, but you got to be more careful with them because you can destroy stuff if you're not being careful. So packets can be permitted or denied based upon where the packet originated, where it's destined to go to, and even what port numbers are in use. So extended access control lists, we can check for what protocol is being used. So at layer 3, we could be using IP version 4, IP version 6. Well, we're forgiven using IP version 6. We'll just use IP version 4 for the purpose of CCNA. So you'd have to know IP version 6 for CCNP stuff. At layer 4, at the transport layer, is it the TCP, Transmission Control Protocol? Is it the User Datagram Protocol? Is it an ICMP thing like pings? Some companies filter pings. They don't want you performing reconnaissance on their internal network. The operand is greater than, less than, equal to. Normally we set it equal to the port number. So for example, in this chart below here, we've got FTP ports 20 and 21. Telnet port 23. A simple mail transfer protocol port 25. DNS port 53. I put a video on the recorded presentations about how to hijack DNS and be a man-in-the-middle attack. Trivial file transfer protocol is what we use to update our Cisco routers and devices with. Simple network management protocol. Oh, routing information protocol was the original routing protocol of the internet. It's finally been taken out of CCNA. No more RIP, no more EIGRP. We just have OSPF now. So here's an example of extended access control list. We have some statements here, and we have a particular IP address, 172.16.6.0, 0.0.0.255. What is to be permitted? What IP addresses are to be permitted with that? Well, 0.0.0.0 must match exactly. If your IP address is 172.16.6.anything, you match and you're permitted. If it's a telnet, or it's FTP, or if it's FTP data. Any other protocol, like port 80 for web, port 25 for email, that's not taken into consideration here. It would be denied by the implicit deny any. We are going to do the same thing we did with the standard access control list. We're going to link it to an interface in the inbound and outbound direction. So we go to the config-if prompt for, say, G00 or G01, and apply the IP access group number, whatever number it was, to that particular port. You can run an access control list all day long, but until you apply it to a port in the inbound outbound direction, nothing takes place. Okay, let's use this in principle. What if we wanted router A to permit only the guy encircled here, the engineering manager? We only want him to be able to access the web server in the administration department. And that web server has the address of 172.16.10.2, and of course, port 80 is the well-known port for web activity. All other traffic is to be denied to that particular server. How are we going to do this? Okay, so we're going to go to router A in an outbound direction. This Ethernet 0 port, that's the circle at the bottom of router A. And we're going to put the access list 110, which means extended. Permit TCP host 172.16.50.2. That's this guy right here, engineering workstation. That's the source address. What address is he allowed to go to? The destination address. That server right there. What port number is he allowed to use? Port 80 for web. You can't go email. You can't do telnet. You can't do FTP. You can just go to the web service. And then we'll apply it to the Ethernet 0 port in an outbound direction. Number 10 that he 110 that he created must match, and we bind it to the interface port. So why, he says, why in the slide? Why is it better to put it on router A instead of router C? Why is the Ethernet 0 interface being used instead of the 001 interface? And Rick's going to tell us here in a little bit. Rick, the guy that wrote these slides. Now, let's take another example. What if we wanted router A to permit any workstation on the sales network to be able to allow access to the web server back in the administration department with the square red? All of the traffic is to be denied. Okay, so instead of one workstation, we're going to use several workstations. Okay, so access list 110, let's permit anybody whose IP address is 172.16.30.anything, because the 3 zeros mean must be 172.16.30, and the ones means .anything. That host address, however, must be exactly that host address, that specific server that's the web server, and only for port 80, which is web activity. And then go to router A and apply it to the Ethernet port in the outbound direction. As a hint here, you can use the question mark, the built-in context-sensitive help that's present in the Cisco IS. Anytime you do any Cisco command, if you forget what the next part should be, type as much as the command as you know, and then type the question mark, and the built-in context-sensitive help will immediately show you what the next possible thing you should type in should be. And that works even when you go to take the CCNA test. The question mark works. You don't get to bring any reference materials, but that works on the test. Okay, inbound access control lists. We want to use it inbound if possible because it's more efficient, because the iOS checks the packets before they go to this cumbersome, time-consuming routing table lookup process. And let's quench it in the bud. If it's going to be dropped, can we drop it before it costs us a bunch of routing table lookup activity? With an outbound access control list, you've got to wait for the packet to go through the entire routing table lookup process, because only then will it decide which interface port it's supposed to be sent to go out. Afterwards, it's not known until the forwarding decision is made by the routing table lookup process. And now we spent all these precious CPU cycles looking up a packet, and then we dropped it. It'd be better to drop it before it goes through the routing table lookup process, if it's possible to engineer your solution, architect your solution to do that. Okay, so look at these first three statements here. And they're going to allow telnet, and they're going to allow certain hosts to do back and forth. And the slide is saying you don't need the first three entries because TCP includes telnet, IP includes TCP, user data protocol, and ICMP. So you could simply use this last statement to permit that instead, and it would allow all those. Permit IP permits all IP activity at layer 3 and 4. Now, if you do need to zoom in on telnet, for example, you would say permit TCP equals telnet if you wanted to permit to deny specifically telnet. Now, named access control list. What if even if I have the 100, 1 through 99, and I have the extra bank of 600 or 700 they give you, what if that's not enough? And what does 99 mean and what does 98 mean? So can I just, like if I'm writing a programming language and I make up a variable name, I can make it something that makes sense, like employee payroll file. So named access control lists are an alternative for using numbers. And since Cisco iOS software 11.2, well, that came out about 15 years ago. So it's in them all now. So instead of making up a number from 1 to 99 if I want a standard list, or from 100 to 199 if I want an extended list, I'm going to give it a name that makes sense, like internet filter or sales department filter or something like this. So I can it's more intuitive. I can identify an ACL using a name that makes sense. So I'm not limited to the 798 or 799 for standard and extended. Another feature is that named access control lists have better editing. If I want to modify the access control list, I can modify it without maybe having to destroy the whole thing and go into Notepad and reordering my statements and fix them and then paste them back in. So a named access control list, I can delete statements, but I can only put a new statement at the end of the list. So even so, you probably should use the text editor to create them. Now, having said that, the newer iOSs have a feature that will, if you've ever taken a programming course like in BASIC or something, you have line 10, line 20, line 30, and then if you want to put a new statement between line 20 and 30, you put a statement line 25. There's a line numbering feature in the newer iOSs where you can take your previously created condition list, access control list, and you can put something in between lines to fix it. So in this example, he's created an IP access control list, and he wants it to be extended, and we have taken away the ability of the iOS to say, well, if it's 100 to 199, it must be extended. If it's 1 to 99, it must be standard. We have to tell him. So he puts the keyword extended. And then instead of saying a number from 100 to 199, he puts a word that makes server-access. Oh, this must be some list that controls access to the server. The prompt changes to the practical prompt we have never seen before. We're configuring an extended named access control list. And this one has a couple statements to permit TCP for simple mail transfer protocol, port 25, and permit UDP for the DNS lookup function. DNS lookup is UDP. And then the last statement says, deny all of the traffic. And the log keyword, it'll send it to a log file we can use to troubleshoot our statements to make sure they're working properly. I have to apply it to make it sense and do anything. So he's going to go to the fast Ethernet port 00 and apply the access group server access in an outbound direction. So that's an example of using named access control lists. So we're going to do the same thing we would do before. We're going to specify one or more conditions to be permitted or established. And it'll do the same thing as if it were a numbered access control list, except now we have a mnemonic name that makes it easier to remember. So here's an example. In red, we have got an access control list called Internet Filter. It permits the 10.1.1 address and denies all of the traffic. And then we have a blue list that's an extended access control list that permits the telnet function and denies some other functions, and then logs it. Now, here is a little bit about placement of ACLs. The general rule, if this is a standard access control list, remember in that point before where we tried to put the standard access control list on the router in the middle and eventually put block traffic, legitimate traffic from the administration department to the engineering department? We didn't want that. The problem is standard access control lists don't specify destination, so we have to put it as close to the destination being protected as possible. But we have a bunch of useless traffic that crosses an expensive WAN link, and then it finally gets filtered. It's better to use an extended access control list. We can put that as close as possible to the source of the traffic denied, in this case our boss's worthless nephew, and nip that traffic in the bud before it consumes all our bandwidth across the rest of the network. So this is an example of access control lists can both do a security function as well as shape and control traffic and reduce the total amount of traffic that we need to do. So if they're placed in the proper location, if our access control list is placed in the proper location, it can filter traffic and reduce the entire burden of bandwidth on the entire network. So if traffic is going to be filtered, we should put that access control list where it has the greatest impact on increasing efficiency of the network. Okay, in this particular company, the policy is to deny telnet or FTP traffic from the router A's LAN to router D. All of the traffic must be permitted. The best thing to do would be, as he has done it here in the red square, he's denied FTP and he's denied the telnet traffic, and he's permitting all of the traffic. And the denied FTP and telnet traffic is being taken away close as possible to the source. It's not wasting all that traffic until it gets to the other office at the remote location, and then that traffic is denied. If it was a standard access control list, I would have to put it in that blue square location, way back where the traffic has gone from one location to another location across our wide area network connection and increasing traffic. So here's an example of the code for this. We're going to go to the fast Ethernet port F01 on this router right here, router A, and create an access group 101 inbound, and we're going to deny TCP, and we're going to deny FTP, and permit all other traffic. So Here's an access control list that has a permit statement in it. Access control lists that don't have at least one permit statement in them don't do any good. They just shut down the whole, very expensively shut down the whole traffic out of any device. So we place this extended access control list on router A. They don't cross router A, they don't cross router B, they don't cross the WAN interface to router C and router D. They're nipped in the bud. Legitimate traffic is still permitted. If the permit IP any is not used, if I didn't permit this, if I didn't put this in, I have no permits. Everything is denied. If it matches the first two lines, it's denied because it was telnet or FTP. Then it has the implicit denying, which means you're denied. I don't care what you are, you're denied. So be sure and permit IP, not permit TCP or UDP. If I say permit TCP, no UDP traffic takes place. Oh, nobody can do any DNS lookups. If I permit UDP traffic and no TCP traffic, nobody can go to the web server. So permit IP at layer 3. If I did it with standard access control list, I would have to put it over here in the blue square over the right-hand side. I can only filter on the source address. So in this case, denied 10.0.0.0 and permit everything else. So that's more clunky. And the traffic has to go all the way across our expensive network to here before it finally gets permitted, before it finally gets denied. So better to use extended access control lists and put them close as possible. Object lesson here. Okay, what is a firewall? Oh, that's an expensive thing we got from Palo Alto Networks. It was $250,000, and it's a very sophisticated device that only allows legitimate traffic to come into our network from the outside world and also control maybe employs exfiltrating device back to the outside world. So it exists between the users and the outside world, normally to protect us from intruders. We have some of our intruders come from the outside world, but actually in most companies today, we have to worry about our own employees as well. What if they're a corporate spy that got a job at the help desk? So a firewall would normally consist of several different machines that work together. We could use access control list in firewall routers. And this gives us some point of isolation. So we can put an access control list on routers positioned between 2 points of the network to control traffic exiting or entering a specific part of the internal network. So in this example, we have the internet, okay, where anything goes on the internet, okay, Wild Wild West. And then we have our gateway router that attaches our company to the internet. This red lightning bolt thing is our internet service provider connection to the internet. And then we're going to have our, I'll call it our Bastion server, our server that's on our facility that has our public web page where people can come and buy our products. As our public web server so people can send us email to the marketing department. And then we're going to have another router and further isolate our actual internal people from this area here, the so-called DMZ, demilitarized zone, where our public-facing devices are located. So we'll allow some traffic to get, we're going to allow port 80 to get to that web server. We're not going to allow port 80 stuff into our internal network because people use it for nefarious purposes. So usually we have this sort of trusted internal network that we highly controlled. We have our public-facing network, which is somewhat filtered but not completely open. And then we have our internet network, which is totally beyond our control. We can't do it. That's an untrusted network. We can't do anything with that. We have no control over that. This is a thing that most internet service providers put. You remember our RFC 1918 addresses? Like at home, you're 192.168. something. At Tarrant County College, we use 172.16 for our Wi-Fi's. We use 10. Networks for our plug-in wireline Ethernet stuff. So these are internal addresses that should never be present on the public internet. If someone is trying to spoof an IP address and pretend to be, like say, what is my address at my teacher workstation? It's 10.144.100.1 or something like that. Well, I'm going to make up a spoof an IP packet and make my address 10.144.100.1 and send it to my ISP so I can get right into the TCJC internal network and mess with stuff. That's not going to happen because all the ISPs using a list suggested by Cisco will deny all traffic that has any IP addresses that are these prohibited addresses on the outside world. RFC 1918 addresses are only allowed on private inside networks. They're going to be network address translated into a public address. We'll get that in a later chapter coming right up. So IP packets coming in my network should never have a source address in my network. And Cisco has got a white paper that tells you how to do this. So we have to, we'll learn in a later chapter, we have to network address translate that values into a global unique address that's a allowable public address on the internet to take place. Our last topic is an alternate method for preventing traffic to get to, you know, when we do that line that says line VTY04, password, Cisco, login, allow traffic to come to our people to allow the telnet or secure shell into the router to manage it. Well, we only want the people in the IT department who are authorized to do so to do this. We don't want anybody else to maybe try to guess passwords and get it. So an alternate method of protecting this is create a standard access control list. And let's say that our IT guys are all 172.16.1. something or 2. something. So we're going to allow those addresses. If there's any other network in the company, it'll be 172.16.3, 4, 5, some other third octet number. They will not be permitted. They'll be denied. Then we're going to add one additional line. We do our line BTY04, login, password, Cisco. Access class 2N. It's not access group, it's access class. Slightly different syntax. And thereafter, any attempts to telnet or secure shell into the device, if they don't have this source address, one of these 512 possible source addresses, tonight. So this is an additional, you know, security is layers of an onion. We're going to put passwords. We're going to do access lists. We're going to do whatever we can so that if a guy gets past one measure, maybe he won't get past the second measure, and he'll be okay. Won't be okay. He won't be able to get in there. So standard and access, extended access lists apply to packets traveling through a router, but they don't block packets that originate from within the router. So if I do an outbound telnet extended access list, it doesn't prevent router-initiated telnet sessions by default. So we can use this other method as a way of increasing the security. I think that's the end of our list of our slideshow deck for today. Okay, so I'm going to hang on. First of all, let me stop recording. Stop recording.